Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to be discussing subscripts and coefficients. Okay, because now that we're starting to consider chemical reactions and chemical change, that we need to get a little bit more familiar with the language and the representations in chemistry, specifically in chemical equations. Now you already have some experience from the past of working with chemical equations, symbol equations in particular, but you may think that you understand it quite well, but it can be quite a confusing thing to wrap your head around. And so we're going to spend a bit of time to help tease out some of the differences, perhaps confirm some things you already know and are good at, or maybe sharpen up some things that you're not. Okay, so when we're thinking in chemistry and the language that we use in chemistry, these are two types of numbers that we encounter. The first one that I'm going to deal with is what we call our subscripts. Okay, so I've written down a chemical formula that hopefully you're all familiar with here, and if not, I think you're probably in the wrong course. But at any rate, it's this number that I've highlighted in the blue here. This is what we refer to as our subscript. Okay, so a number that's written down below the rest of the formula. Okay, it represents the number of that atom or ion in the formula. Okay, it comes after the element it refers to. Okay, so the 2 here refers to the hydrogen and not the oxygen. Okay, that's important to be able to recognize. And also that no subscript equals 1. Okay, so if it's written there but there's no subscript, that means that there's only one of that thing there. So in this formula, I don't need to write H2O1. I just know that if I'm not writing any number here, then I'm assuming that it's 1. Okay, so that we can use this same sort of, this newfound knowledge of what subscripts are to then kind of look at any chemical formula that we encounter, say this one here, and to be able to identify how many different things there are present in here. So we've got one, we recognize that this is an ionic substance, we've got one calcium 2+, and then we've got 2 lots of the hydroxide ion that is in the brackets. Okay, the subscripts here refer to this thing, and then we keep the brackets to show that, if we had written it like this, then we would imply we'd have 2 hydrogens but only 1 oxygen. But by using the brackets, we've got 2 lots of both of those things. Okay, and so now I'm going to show you though, now once we start to build chemical equations, this gets a little bit more complicated. Okay, so I'm going to show you one example of a chemical equation to illustrate the point here. Okay, so if I go through, I can see I have a number of different numbers here. I've got these ones, and then I've also got these ones just up here. Okay, so we've already identified that these numbers that are written down below are our subscripts. Okay, that we've just talked about exactly what that means, that they refer to how many of a particular element there are in a given substance within a particular particle. But what we have here, these ones up here, are what we call our coefficients. Okay, just like we use coefficients in maths equations, if I write 2x plus 3y equals 10, my coefficients are my 2 and my 3 in this situation, the number that comes before the x and y. Okay, so the coefficients tell us how many particles of that substance are reacting / present. Okay, how many particles of that? So if I'm looking at this, what I can see is that now there's and the same sort of thing here, that no coefficient isn't 0 but also equals 1. So it's like saying I've got 1 here, 1 of these plus 3 of these forms 2 of those. Okay, so the idea here is that it's saying that I have one nitrogen molecule reacting with 3 hydrogen molecules to form 2 ammonia molecules, which is what this one is over here. Now I'll just clear off the writing underneath here, and then I'll illustrate that. I would use my coloured buttons, but I don't have them at the moment, but I'll just draw this out for you, okay, underneath to help visualize this a bit better. So I've got one nitrogen molecule, and I'm going to draw it like this just so you can kind of get used to that. And then plus 3 H2 molecules, which look like, I'm going to draw like this, forming 2 NH3 molecules. And I'm going to draw them like this in this kind of triangle sort of shape, so you can get used to seeing this. Okay, so I've got one of these plus 3 of these forming 2 of these. Now, the reason that these coefficients are important is that we need to express a particular amount of each of these substances that's present. Okay, and the reason for that is pretty simple, is that the law of conservation of mass tells us that every atom that was there at the start must be present at the end. All matter is accounted for. That was something that Dalton was working with. This is not a new concept. But what that means is that now every N I write over here needs to be over here as well, and every H over here needs to be accounted for here as well. So I've got 2 nitrogens and 6 hydrogens. Over here I've got 2 nitrogens and 6 hydrogens. Okay, what we're going to be learning about in this is that how to balance a chemical equation, how to actually use coefficients to make sure that all atoms are present and accounted for at the start and at the end. Because remember that this is a before and after process, that we've got these things rearranging to become those. Okay, so the coefficients, the numbers that come before these substances in an equation, help to express how many of that molecule or particle is present. Okay, so you can see that each of these numbers, subscripts and coefficients, are vitally important but mean something different in chemistry, and we need to be very comfortable and familiar with what they show us and how we work with them to be able to identify how many particles are present. All right, thanks very much for watching. Bye for now.